Hello, mathematicians all around the world and especially at OA at Oyster Adams Bilingual School. Today, this is Mr. Smith for math. I teach math for 4th and 5th grade, and this is about distance learning. I'm pretty sure a lot of you received a lot of work on iReady, on Zern, on Imagine Math, on ST Math, all of the above. And in your workbooks, you probably know that you have quite a bit of word problems to solve. So this video serves the purpose of giving you some helpful suggestions on how you can solve word problems in a far easier way. So this video is called Word Problem Schemas. We're going to get into that in a moment. What is a schema? Our objectives today are this. We will categorize word problems into different schemas. Remember, schemas are like big ideas. They're like groups of information. And our language objective is we will say these two things. This word problem fits into the blank schema because, or the operation I can use to solve this problem is blank. With it. So we have some interesting vocabulary here. If you look at the picture on your left, if you look here at this picture right here, it's going to show that picture right there, the head with the things inside of it. Well, those are different pictures because schemas are ideas that we have in our head. For example, a schema that a lot of people are familiar with are bicycles and also ice cream. So the schema of bicycles are, I can have the big group called bicycles. And there are different types of bicycles. There are red bicycles, there are green bicycles, there are blue bicycles. But they all fit into the same schema of being bicycles. Just like ice cream is one big idea in one group. You can have chocolate ice cream. You can have vanilla ice cream. You can have strawberry ice cream. You can have dairy-free ice cream. But they all fit into one big schema or one big group. So we will define a schema as ideas organized into categories in our brain. Now we also have the second picture on the right. You see a plus, a minus, a multiplication, and division symbols. These are symbols that look very familiar in math. We call those our operations. These are things that we do with numbers and amounts of different things. So either we're making things more with addition or multiplication, we're putting things into equal groups with multiplication, division, or we're just getting rid of some things with subtraction or division. So let's continue on. These are two big important words. Everyone say schema. Excellent. Everyone say operations. Excellent. Now here is the first group of schemas. Remember how I said we have different groups? Like we have a part of our brain knows what a bicycle is. That's one schema set. And all different kind of bicycles. Another part of our brain has a schema of ice cream. And all different flavors of ice cream. So in word problems for math, we have two big schemas. We have additive schemas, which is the very first one. And if you see here, you see the root of additive is add. Either we're adding, if you see in the background, a plus sign, or we're subtracting in these schemas. Everyone say additive. Clap it out. Additive. Wonderful. And say schemas. Wonderful. Remember, additive schemas, the operation that I can use are either addition or subtraction. Which two operations can we use for additive schemas? Yeah, you're right, addition or subtraction. Let's look at some examples. Well, you all know what this looks like. This looks like a bunch of blocks we put together. We have 2 blue blocks, 3 yellow blocks. When we put them together, we have our whole. This schema is called, our first additive schema is called total. Because we're looking for the total, we're looking for the whole amount. Now the total schema looks for the whole amount of something. Now, oh, wait a second. This star just appeared on my screen. I wonder what that means. Oh, it's a cognate alert. So throughout this video, every time you see a star appear on your screen, that means it's a cognate alert for some words that in English and Spanish sound similar and or look similar. That's what cognates are. They either sound similar or the same or look similar and the same. In this case, in English, in blue, we have total, and in Espanol, we have total. They both look the same and sound the same. Well, let's keep it moving. Here's some examples that we have. Example number 1. Juan has 2 cookies. Ali has 3 cookies. How many cookies do they have altogether? Well, I'm going to highlight some important information in yellow. First, I know that Juan has 2 cookies. That's important information because cookies is our units. And I know that Ali has 3 cookies. Let's underline our question in red. How many cookies do they have all together? Notice I'm annotating and marking up my question just to make sure it makes more sense to me. So this fits into the total because it's looking for the whole amount of something. Now, the operations I could use to solve this problem are addition. I can say 2 plus 3 is equal to blank. Or I can say blank is equal to 3 plus 2. It's the same thing. Let's look at example number 2. There are 6 students in the classroom and some more students in the hallway. There are 20 students in all. How many students are in the hallway? Well, let's highlight some important things here in green. There are 6 students that are in the classroom, and then there are some more students in the hallway. There are 20 students in all. Now let's underline our question in red. How many students are in the hallway? Well, we don't know how many students are in a hallway. We know how many in the classroom. We know all together there are 20. So this is also a total because they tell us what the total amount of students is and we have to find a part. So we could do it 2 ways. We could do it 6 plus a number equals 20, or we can do it 20 minus 6 equals a number. Either way, that gets us to total. Remember, the total schema looks for the whole amount of something. What does the total schema look for? You're right, the whole amount of something. Which operations can I use for the total schema? Oh yeah, you're correct. I can use addition or subtraction to solve the total schema. Let's move to the next additive schema. Oh, look what's happening here. This looks like a graph. It looks like there are different colors and things are changing each bar. That gets us to the change schema. The change schema looks for the change in amounts. So we're looking for the change in amounts. Well, as we see here, there wasn't a star this time because change and cambio, they don't sound alike, nor do they look alike. So they're not cognates. So let's look at some of the examples. We have a whole bunch of great examples today for a change. Let's look here. So we have Isabella has 3 ribbons. Shay gives her 2 ribbons. How many ribbons does Isabella have now? So something changed here. Isabella has 3 ribbons. That's what she started off with, so I'm going to highlight that. Isabella, 3 ribbons. Shay gives her 2 ribbons. So she got some more ribbons, I know that. And now I'm going to underline my word problem where it says, how many ribbons does Isabella have now? Well, this is about Isabella. She started with 3, and she got 2 more from Shay. So I can say 3 plus 2 is equal to blank. Let's look at the second word problem. Isabella has 3 ribbons. She gave Shay 1 ribbon. It sounds a little different now. Listen to me again. Isabella has 3 ribbons. She gave Shay 1 ribbon. How many ribbons does Isabella have now? Let me highlight some information here because this sounds a little different. Has the same people's names, are still talking about ribbons, but the numbers are different and the scenario and the case is different. So Isabella, I'm going to highlight her name in green. She has 3 ribbons. She gave Shay 1 ribbon. And I'm going to underline my question where it says, how many ribbons does Isabella have now? Well, she started off with 3. She got rid of 1. So 3 minus 1 is equal to blank. Now, the next 2 examples I'm going to go through very quickly, and I'm not going to highlight it this time for the sake of time. Galilea has 9 bracelets. Ashley gave her some more bracelets. Now she has 12 bracelets. How many did Ashley give her? Well, I know Galilea started off with 9. And then Ashley gave her some more. And she ended up with 12. So that's 9 plus something equals 12. Or I could have did 12 minus 9 equals something. Now remember, for change in additive schemas, we can always use addition and subtraction to find our answer. Let's look at the last example here. Galilea has some bracelets. I don't know how many Galilea has, but she has some. Ashley gave her 4 bracelets. Oh, Ashley gave her 4, so she has 4 more than what she started with. Now, Galilea has 11 bracelets. How many bracelets did Galilea have to begin with? Well, we don't know how much she began with. We know she got 4 more. So we're going to say blank plus 4 equals 11. Or, for you wise people out there, how could I write that as a subtraction sentence? Oh my gosh, you all are geniuses. Yes, 11 minus 4 equals blank. Now, there's one more additive schema. Don't let it confuse you with change. It sounds similar, but it's a little different. Oh, look here. We have some apples being subtracted, some bananas being subtracted. I wonder what this schema is. D for difference. So the difference schema compares the amounts between different things. Uh-oh. We see a star. That means it's a cognate alert. In English, we say difference, and in Espanol, we say diferencia. They look similar, and they sound similar. That's what makes them cognates. We have 3 examples here. Example number 1. I'm going to use yellow to highlight once we go through the problem and read through it the first time. The small dog has 3 spots. How many spots does a small dog have? Yeah, 3 spots. The large dog has 7 spots. How many spots does the large dog have? 7 spots. Excellent. How many more spots does the large dog have than the small dog? When you hear the language, how many more, how many less, you're comparing something than something. So let's look here. We know the small dog, highlighted in green, 3 spots. Large dog, you're right, 7 spots. Now here's something I'm going to underline my question. I always need to underline my question to make sure I'm answering the question. How many more? I'm going to circle more because when you hear that, how many more? I'm going to circle many as well. Many more spots does the large dog have Then, oh, that then there also lets me know we're looking for a difference in comparing. The small dog. So remember, I can always use addition and subtraction to solve my additive schemas. So here we have 7 minus 3 is equal to blank. Or you could have did 3 plus a number equals 7. Example number 2, I'm going to use yellowed for the highlighting. Nikolai has 3 more pencils than Nino. You hear that? 3 more pencils than Nino. So I see 3 more than, I hear some comparison happening here. Nino. Nikolai has 7 pencils. Well, we know he has 3 more than Nino. And he already has 7 pencils. So he has 7 pencils. How many pencils does Nino have? Well, So Nikolai has 7 pencils. I know that. And that's 3 more than Nino. So that's going to be 7 minus a number equals 3. So, or you could do 3 plus a number equals 7. All right, next example. Ava, oh, I forgot something. You're right. Thank you, because mistakes are important. Someone just reminded me I need to underline my question. Thank you for letting me know I need to underline my question. We all forget at times. That's okay. Now, last one. This time I'm going to use blue as my highlighter for the last example here. Ava has 9 fewer points than Giovanni. Ooh, I hear Ava has 9 fewer points than Giovanni. Ava has 2 points. How many points does Ava have? You're right, 2 points. How many points does Giovanni have? I'm not going to forget this time, because some people are going to tell me, Mr. Smith, you forgot to underline. You're questioning your word problem. I didn't forget this time. The last time I made that mistake, I'm learning from my mistakes. That's what we all do. I can do blank minus 2 equals 9. Or I can do something else. What else do you think I can do? I could do 9 plus 2 equals a number. Okay, I could try that out too. Now, before we move on to our next set of schemas, I'm going to stop here. Remember that additive schemas, we can use the operations of addition or subtraction to solve those problems. Moving on. Multiplicative schemas, you see division and multiplication. So I'm pretty sure you know which operations you're using. And if you're looking here, I'm going to highlight something in purple. You see where it says multiplicative? Oh, it looks kind of like multiply. So I know I'm multiplying or dividing here. Well, we're back. I wanted to make a quick correction because some things happened. But this schema is called, you see it, there's a scale with 3 people on one side and 3 on the other side. So it looks like it's a equal groups. Equal group schema looks at how many groups hold an amount evenly. So we're looking for the amount of groups and how much it holds equally or evenly that's shared. Oh, we see the star, so we know it's a what? It's a cognate alert. In English, we say groups, and in Espanol, we say grupos. Now let's look at our examples here. Example number 1. I'm going to use a yellow highlighter to highlight some important information. Tara has 6 bags of oranges. How many bags of oranges does Tara have? You're right, she has 6 bags of oranges. There are 4 oranges in each bag. How many oranges are in each bag? Excellent, 4 oranges in each bag. Now, let's not forget that we need to underline our question and see what we have to answer. How many oranges does Tara have? Oh, well, I can solve it this way. I can do 6 times 4 is equal to blank. I have 6 bags with 4 oranges in each. That means I'm multiplying. Let's look at the second example here. I'm going to use orange to highlight here. Darren has 20 comic books. Well, I know Darren has 20 comic books. That's important information. His bookshelf has 5 shelves. He has 5 shelves on his bookshelf. Got it. He wants to put an equal number of comic books on each shelf. So he wants to put an equal number of comic books on each shelf. That language tells me that I'm looking for equal groups because he's looking for equal amount on each shelf. Then I need to underline my question to make sure I'm answering my question. It says, how many comic books will he put on each shelf? Well, I can solve it 2 different ways. I can do 5 times the number is equal to 20, or I can do 20 divided by 5 is equal to a number. So I can either use multiplication or division there to figure out how many comic books will go on each shelf. Oh, looks like there's a seesaw here or some kind of scale. There are 2 apples and there are 3 oranges. In this case, the 2 apples must be lighter than the 3 oranges, must be less than the 3 oranges. So it sounds like I'm comparing again. Oh, I am comparing. So for comparison, the schema looks at how many times an amount repeats. What does it look for? You're right, it looks for how many times an amount repeats. Well, let's look at some examples. Oh, you know it. What is it? You're right. It's a cognate alert. So we have in English comparison. In Espanol, we have comparación. Now, we have these last 2 examples. So, Alex has 6 bags of oranges. How many bags of oranges does Alex have? You're right, he has 6 bags of oranges. Lucas has 6 pieces of candy. How many pieces of candy does Lucas have? Oh, 6 pieces. Mateo has 2 times. Oh, there's 3 people in this problem. Oh my goodness, this is the first time that we've seen this so far in this video. Mateo has 2 times as many pieces of candy. Well, Alex has 6 bags of oranges. That has nothing to do with candy. So I'm going to focus on Luke. So I'm going to X out that. That's not even important information. I'm just going to X that out. It's not even important. I'm just going to put a line through it. That's not important. What's important now is Lucas and Mateo because it's both talking about candy. So Lucas has 6 pieces of candy, and Mateo has 2 times as many pieces of candy. And now I need to underline my question. How many pieces of candy does Mateo have? Oh, remember, with multiplicative schemas, I can either multiply or divide. In this case, I can use 6 times 2 equals blank. Last comparison schema. Pedro, I'm going to use yellow to highlight here. Pedro has 7 video games. How many video games does Pedro have? Oh, you're right. 7 video games. Oscar has 21 video games. How many video games does Oscar have? 21 video games. Sounds like they have a lot of video games. Have way more video games than Mr. Smith. How many times as many video games does Oscar have than Pedro? Ooh, let's look at that language. How many times? Let me use red here. How many times? I see times, so I can either multiply or divide. As many, that means I'm comparing video games as Oscar had then, and I'm still comparing Pedro. Ooh, I could do 7 times the number equals 21, or I can divide and do 21 divided by blank equals 7. Remember, for multiplicative schemas, we can do this. We can multiply or divide. Now, I'm going to go back for a moment and just say, everyone, this is some important information to remember. Remember, recuerda. It's super important. The vocabulary for today. We talked about schemas. They are ideas organized into categories in our brain, like ice cream and bicycles. We also talk about operations that go into those schemas, like addition, subtraction, multiplication, and division. Those are things we do with numbers and the amounts of different things. We have 5 different schemas we talked about today. The first additive schema was total. The second additive schema was change. The last additive schema was difference. We can either add or subtract with total, change, or difference. What 2 operations can we use for total, change, and difference? You're right, addition and subtraction. These are our additive schemas. Everyone say additive schemas. Additive schemas. Wonderful. So I'm going to just draw a little line here. On top, we have either plus or minus for additive schemas. Now let's look here. Multiplicative schemas. Everyone say multiplicative. Repeat that again. That's a lot of syllables. Multiplicative schemas. The first one we have are equal groups. We can either multiply or divide. And the second one that we have is comparison. We can either multiply or divide. So in green, I'm going to write at the bottom a multiplication symbol, which is an X, and a division symbol, which looks like a fraction. That's it. Those are our schemas. That's how we can solve word problems a lot easier. We can think about them as being total, change, difference, either addition or subtraction, or equal groups in comparison, multiplication or division. Thank you for everything. I know that you are going to enjoy looking at this schema of cupcakes and the different flavors that they all have in different colors. So I hope that you can solve these word problems with all your heart and all your might. And remember that there's always a way when you believe in yourself. Mistakes are important, and be willing to take those risks and be creative, because as long as it makes sense to you, it'll make sense to me. Bye.